Okay guys, so what we're going to be looking at here, as you can see, are derivatives of inverse trig functions. Now of all of the different things, all the different derivatives that we talk about in this class, derivatives of inverse trig functions, I'm not going to lie, is probably the least important when it comes to the AP test. It's not that these things never show up, it's just they don't show up very often, and they're very, very specific, so you'll have to kind of just be prepared to know how to take the derivative of one of these if you see them, okay? As a quick review, I don't know if it's probably been a while for quite a few of you guys since you've seen an inverse trig function. First of all, what an inverse trig function is it's something that undoes a regular trig function. Like when I look at a trig function in general, like if I have the sine, we'll call this theta, and this is like, whoops, we'll say this side is 3 long and this side is 5 long on a right triangle. If I'm looking at that, what we learned before is that the sine of that angle, we can call it x or theta or whatever, is equal to the opposite side over the hypotenuse. And when we take the sine of a specific angle, we're just saying that that is the ratio of the opposite side to the hypotenuse in any given right triangle that has that particular angle. When we see the inverse sine of something like we see down here, what that is asking is it's asking what angle, if I were to take the sine of it, would give me this particular ratio right here, the square root of 3 over 2. Now that should sound vaguely familiar because you learned it last year when you were taking Math 3. It's honestly not something that we use a ton in this class in particular, but inverse trig functions do have a place, and they have a huge place actually when you're looking at trigonometry, so that's just not something that we're going to be looking at a ton for in this particular class. So this should be actually a fairly short video just because I'm just going to tell you what the derivatives are. We're not going to talk about where they come from, and then we'll look at how to use them. So the first one is, let's say I wanted to know the derivative of the inverse sine of x. Now one thing I do want to call your attention to real quick is this -1 does not mean that we're going to use the chain rule. And it's only with -1, and I think it's the most confusing thing about inverse trig functions, is they have an exponent that is -1. Again, that's not saying that it's being raised to the -1 power. That just means that we are looking at the inverse of the sine. So anytime I want to take the derivative of the inverse sine of x, I just use this formula right here. The derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. And this is just something that you have to have memorized. So if I had something like this, like what is the derivative of 3x squared plus the inverse sine of x, we would just again take the derivative a term at a time. So I'd get 6x plus, then we just found the derivative of the inverse sine of x is 1 over 1 minus x squared. And we'd be finished. That's all we would have to do to find that derivative. So there's no rule to apply per se. It's just a memorization of this is the derivative of the inverse sine of x, which is kind of nice. Like it really is nice that that is what the derivative turns out to be. If I want to know the derivative of the inverse cosine of x, you'll notice, and this is one thing that kind of confuses people a little bit, the derivative of the inverse cosine of x is exactly the same as the inverse sine of x, but there is a negative sign out in front of it. So again, it's identical in every way, and it has to do a lot with the shape of the graph and how we can manipulate that a little bit to find the inverse cosine of x. Nothing you have to worry about a ton, but that's why they look almost identical. So if I wanted the derivative of the inverse cosine of 5x, what we see here is, you can see we've got a 5x in the parentheses. So that means that there's going to be a chain rule of some sort. Now, in order to apply that chain rule, what we do is we leave the derivative the same. So I go -1 over the square root of 1 minus, and instead of putting x, and this is very similar to how it worked when we had trig functions, what I put in its place is whatever the inside function is. So in this case, that would be 5x. So I'd go 1 minus 5x squared. Then I would multiply by the derivative of 5x, which is just 5. So the derivative of this function would be -1 over the square root of 1 minus 5x, all being squared, multiplied by 5. And again, the 5 is off to the side, not on the bottom of the fraction. Sometimes people like to try and put that on the bottom of the fraction, and that's just not how that works. The derivative of the inverse tangent of x is 1 divided by 1 plus x squared. And of all of the different trig ratios, the trig functions that we look at, strangely enough, this one is by far the most important. The inverse tangent has a lot of uses in Calculus BC, and you'll get to that if you decide to take that class. If not, just memorize the fact that it is 1 over 1 plus x squared, and you're good to go. So if I saw something like this, where I wanted the derivative of the inverse tangent of x, then that would be 1 over 1 plus, instead of x, because cosine is our inside function here, I would have cosine of x squared, and then we would multiply that by the derivative of cosine of x, which would be negative sine of x. Oops. And that would be our answer for this particular derivative. Again, not that difficult. The other derivatives that we're going to look at are all somewhat important, although honestly I've never seen any of them show up on the AP exam. And there's a reason for that. Technically, you can find all of these, although it's not something we're going to talk about. Technically, you can find all of these just by using some manipulation using sine, cosine, and tangent. So again, I'm just going to put these up on the screen. I'm going to read them, and I'm not going to spend a ton of time talking about them because they just don't show up on the AP test that often. So, the first one that I want to look at is what is the derivative of the inverse cotangent of x? The inverse cotangent is negative 1 over x squared plus 1. It's basically just the inverse tangent with a negative sign out front, because I can write x squared plus 1 and 1 plus x squared in either order, and it means the same thing. So that's my derivative of the inverse cotangent. The derivative of the inverse secant of x, and this one looks complicated because it's got x's in more than one place, is 1 divided by the absolute value of x, and then we multiply that on the bottom by the square root of x squared minus 1. So if I was using the chain rule with the inverse secant, I would put whatever's in the parentheses both there and there. Okay, there's no problem with having it in two different places. That's just where it would go. The derivative of the inverse cosecant is negative 1 over it's exactly the same as the secant. It's just negative 1 over the absolute value of x times x squared minus 1. Again, this is not one that I would expect you to have memorized for the AP test just because it really doesn't ever show up. But if you ever need to use it for something, there it is right there. So the one thing, and this won't be a big deal until we start talking about the second half of this class, but one thing that we have to realize is when I am looking at an inverse trig derivative especially, know that they're always of the form 1 over, the ones that are important anyway, 1 over 1 either plus or minus an x squared. They all look very similar. Like honestly, knowing secant and cosecant, as it says here, are basically worthless. But sine, cosine, and tangent, recognizing their derivatives, will be a little bit more important as we move forward. Again, of all of the things that we discuss in this class, of all of the derivatives that we talk about, this is the one on the AP test that gets used the least. And so kind of take that with a grain of salt, saying, okay, maybe I should learn these, but it's not like vitally important for me to pass the AP test. It'll help, but if I don't know these, it's not going to be the end of the world. If you have any questions about these, please come on in and ask.